Our today's topic is B tree, and we will discuss in this introductory part what is B tree and how we can insert a element into B tree. So before introductory part of the B tree, we have to understand what is M-way search tree. Just like binary search tree, M-way search tree is the tree in which the search operation we perform in most efficient way. But in the binary search tree, at each node we store just one element. So M-way search tree is the most generalized form of binary search tree. And the B tree, you can say, is the most balanced generalized search tree. So if we compare, then binary search tree का generalized form M-way search tree and AVL search tree का most generalized form, that is a balanced search tree जो है AVL search tree उसका most generalized form B tree. So firstly, I will talk about the M-way search tree and its property and then B tree. So what is M-way tree? Only two children per node? No. So we will have like this structure, and that's why the time complexity will become O log n base M, because the order of the tree will be M now. What does it mean? When I'm saying the order of M, that is for M-way search tree, the order will be M. If the value of M is 4, then for example, the key value will be M minus 1, that is 4 minus 1, that is 3. So only we will have 3 key values and M children. So M children and M minus 1 keys per node. So this is the basic idea of M-way search tree. Order M, if we have order M, then M child, maximum M child and M minus 1 values, key values per node. And the structure of the organization of the element will be like all the element in this subtree pointed by T0 will be less than K1. All the elements in the subtree pointed by T1 will be greater than K1 but less than K2. Similarly, all the elements pointed by T2 in this subtree will be greater than K2 but less than K3, and all the elements in the subtree pointed by T3 will be greater than K3, and the key value in the node itself will be as like K1 less than K2 and K2 less than K3, that is in sorted fashion. So this is the idea of M-way search tree. So if the order is 10 and we want to know how much element can be at level 6, then it will be 10 to the power 6 key. Just like in binary uh, tree, 2 to the power the level we compute. So, but you have to search through the M keys in each node. We have, suppose I want to search an element, then firstly I have to check whether it is less than K1. If it is so, then I will come here. If it is greater than K1 and less than K2, then we will come in this subtree. If it is greater than K2 and less than K3, then I will come here and so on. So at each node, there may be more than one comparison. Now, what is B tree? So all leaves are on the same level. In M-way search tree, it is not the case. But B tree is the balanced M-way search tree. B tree is balanced M-way search tree, and that's why all the leaves are on the same label. Each node is at least half full of the key. Whatever the order of the tree will be, but it will be half full. And how and it will ensure that all leaves are on the same label. All nodes except for the root and the leaves will have at least m by 2 children and at most m children. A most generalized definition is here. This B tree was invented by Baer and McGrath in 1972, and I said B tree is a balanced M-way search tree. B tree is a balanced M-way search tree. Suppose we have a B tree of order M, then it is a M-way search tree with following property. As I said, all leaves are on the same label. Root have at least two child nodes and at most m child nodes. Internal node except root have at least m by 2 upper bound child nodes and at most m child nodes. And the key organization at the node is similar to M-way search tree as I discussed. Okay, एंड डेफिनेटली जितने आपके चाइल्ड नोड्स होंगे लेस देन वन की वैल्यूज होंगी नोड पे. दिस इज द पॉइंट हियर. नाउ इंसर्शन, how we can insert a element in the B tree. As I said, B tree की property at least half full होना चाहिए. So insertion, after insertion, if the node becomes overflow, then we will split it and we will promote one middle key. And if parent node is again overflow, then we will split parent node too, and so on. Take this example. This is the element we have and we want to insert. Then one by one I am discussing. This jet empty hai, so simply insert it. U simply insert it. U is less than z, then it will be left. A सबसे पहले आएगा in sorted fashion at each node, k1 less than k2, k less than k3 and so on. So in the sorted fashion at each node the key values will be stored. I, so I is greater than a, less than u, then it will be here. Now suppose order of the tree is 4, then then there may be maximum m minus 1, that is 4 minus 1, that is 3. Only three key values can be at most. So it is overflow condition. So how we will split, how to split? And firstly, m by 2 my upper bound minus 1 key are moved to left child. M by 2th key will be moved to upward as a central key, and remaining will be moved to the right child. So this is the simple procedure. We have m is equal to 4. So m by 2 upper bound will be 2. Okay. So m by 2 upper bound minus 1 will be 2 minus 1, that is 1. So one element A will be left child. M by 2th element will be moved upward, that is second one will be moved upward I here, and remaining uj will be moved to the right child. So after a split it will be this one. Now after insertion of w it will be here, no overflow. After insertion of l it will be greater than I, then it will be at right. So you can see here again LUWZ, it is overflow condition more than 3, then split hoga. So one element L will be left child, WZ in the right child, and U will move to upward. So U is here, you can see U is here. So L will be in the left subtree of U and WZ will be in the right subtree of U. Then P is greater than I, less than U, then it will come here. so it is no problem. X, it will be here, it is greater than U, that's why. Greater than W, less than Z, so it will be here. C, less than I, here. J, greater than I, less than U, here. D, less than I, here. M, it is less than I, greater than I, less than U, so it will be here, and this is overflow condition. So it will be splitted. So L will move upward. L is upward now. One node J will be in left subtree of L, and remaining MP will be in the right subtree of L. T, T will be here. It is greater than L, less than U. B, B will be here. Now overflow condition, B will move upward. A its left child, CD its right subchild. Yeah, right subtree. Now, after moving this B upward in parent node, again we are saying this is overflow condition. So again this I will move upward. This I will move upward. So B left and LU at right. Then Q. Q is, greater than I, then it will move here, and it is greater than L and less than U, so it will be here. Now it is overflow condition. So it P, again, this P will move upward, M will be its left child, and QT its right. So you can see here, P moved upward, M become its left child, and QT its right. After insertion of E, you can see this E is less than I, then greater than B, so it will be here. H is less than I, greater than B, so it is here. Now overflow situation, D will move upward now, so D moved here. See its left one, and EH its right. Then S is greater than I, then greater than P, less than U, so S is here. Now K, I think you all understood, but again I would like to complete this example. Then K, you can see K is greater than I, then less than L, so it is here. Now N is here. Then R. Now R will be greater than P, less than U, so it will be here. So it will be QRST. Then it will be splitted. R will move upward, Q less left child, ST its right child, and then R, when it will move to upward, then it will become LPU. LPU become LPRU. Then it will be splitted again. Then P will move upward. So P moved upward here, I. Then you can see P is here. Its left one will be L, and its right one will be RU. And this JK is left of LK, MN is right of L, and RU is the right of P. So left of R is Q, and right of R is ST, and U, right of U is same, no change. So it is a very good example. So you can observe. Then G is here, no problem. Y, Y go to this node, so overflow, so it will be splitted. So it is splitted now like this. You can see F will be here, so again it will be splitted. EFGH, so EFGH. Now O, so O will be here, and V, so V will be here. So this is all about the insertion in B tree. So this is all about today's topic. So enough for today. Thank you. In the next lecture I will start graph.